Today's lesson is on one-to-one. I can identify if a function is one-to-one. One-to-one functions are functions as rules can be divided into various categories based on shared characteristics. One category is comprised of functions known as one-to-one. The following exercise will illustrate, that was very bad English, the difference between a function that is one-to-one and not one-to-one. Exercise 1. Consider the two simple functions given by the equations f of x equals 2x and g of x equals x squared. Map the domain -2, 0, 2 for each function. Fill in range and show the mapping arrows. So in the first function, f, we have 2x as our rule. So -2 times 2 is -4. 0 times 2 is 0. And 2 times 2 is 4. For our function g of x, our rule is x squared. So -2 times -2, or -2 squared, is 4. 0 squared is 0. 2 squared is 4. What is fundamentally different between these two functions in terms of how the elements of this domain get mapped to the elements of the range? So the range of g of x has a repeating value, correct? Alright, so let's look at what one-to-one is. A function for which every element of the range of the function corresponds to exactly one element of the domain. One-to-one is often written 1-1. Notice it has to be a function. So in order for it to be a function, each x has to have only one y. In order for it to be one-to-one, each x has to have only one y, and each y has to have only one x. So be very careful that you don't just see, that the range has to have exactly one element of the domain. Remember, it has to be a function. So neither x nor y can repeat, okay? So in exercise 2, of the 4 tables below, one represents a relationship where y is one-to-one of x. Determine which it is and explain why the others are not. So if you look at this first one, we know this is not one-to-one because x repeats. Number 2, the x's are good. Because the y repeats. Number 3 looks good. And number 4, both repeat. So number 3 is because the y values and the x values cannot repeat in order for it to be one-to-one. A little bit harder to see with a graph than a table. So what could we do? Well, we know that to be a function, it has to pass the vertical line test. Well, 1 is a function, 2 is not a function, 3 is not a function, 4 is a function. So I can eliminate 2 and 3 because they're not functions. And if it's not a function, it can't be one-to-one. So then, what about 1 and 4? Well, in order for it to be one-to-one, then it has to pass the vertical and the horizontal. So, we know that choice 1 doesn't pass, it's not one-to-one. because it doesn't pass vertical line test and horizontal line test. Number 4, yes, it's 1-to-1 because it passes both vertical line test and horizontal line test. Okay? In choice 4, each x has one y, each y has one x. So the horizontal line test passes through the graph of a function, hence word, function, at most one time. Then that function is 1-to-1. The test works because horizontal lines represent constant y values. Hence, if a horizontal line intersects a graph more than once, an output is repeated. And that's what we talked about in the table. So second to last example, example 4. Which of the following represents the graph of a 1-to-1 function? Well, let's start with this. Is it a function? Not a function. 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 So now let's do horizontal line test. So since this isn't a function, we already got rid of it. So, doesn't pass horizontal. Passes horizontal. Doesn't pass horizontal. So our answer is choice 3. And the last example, exercise 5. The distance that a number x lies from the number 5 on a one-dimensional number line is given by the function d of x equals the absolute value of x minus 5. Show by example that d of x is not a 1-to-1 function. So pick a value for x. Let's say d of 1. So we have 1 minus 5 in the absolute value. So 1 minus 5 is -4. The distance that -4 is away from 0, which is the definition of absolute value, is 4. So is there another value that is also 5 away from 0? So what number could I put in here that equals 4? Yes, 9. So 9 minus 5 is 4. The absolute value of 4 is 4. So it is not 1-to-1 because I have the ordered pair of 1, 4 and 9, 4. And if either x or y repeats, it is not 1-to-1 because y repeats. Absolute values, if you graphed this, you would notice it passes the vertical line test. It's a function. Its inverse is not a function. Therefore, it's not 1-to-1. If you have any questions, please make sure you ask. Good luck.